Hello, everybody. Today I'm going to be talking about superconductors, what they are, and an analogy that I came up with. So let's get started. Briefly touch upon superconductors and the analogy I have. I'm going to just talk about a little bit what they are. So superconductors we can conduct electricity with the potential of not losing any energy in the process unless it's used for something. In order to accomplish this, there needs to be very, very cold temperatures, near absolute zero. Not quite complete absolute zero, but as close as possible. And different types of superconductors reach that um, one-to-one ratio, if you will, at different low temperatures. And at this, there is no resistance. I'm using this as a analogy for like space travel, like a comet or a rocket flying through space. Once you push that initial um, amount of thrust or energy into it and starts moving, it'll just keep going unless it gets hit by something or gravity or anything. But without any of that, it could keep going indefinitely. And this is similar to how superconductors work in a sense. Anyway, let's move on. Okay, so why I chose superconductors, I thought it was pretty cool that magnets um, are used in like China and Japan to propel trains forward by levitating them slightly off the ground, and this produces very little friction by propelling them forward. This is known as the Meissner effect, which you can see in the image to the right. It's a little floating magnet, and it's a byproduct of superconductors. Um, with Another thing that's cool about it is the current could continue forever potentially, unless it's used for something. I recall researching something about um, some current stored in some project like 30 years ago, and the same the same amount of current is still in the actual the circuit, just still now 30 years later because of the lack of resistance. It's also good for the environment. Less energy lost to resistance and in the process of conducting anything is always great. So the more we can go over and build upon this, the better it will be for everybody. I also like space. I mean, who doesn't, right? Space is pretty cool. Objects keep on going forever. Um, Superconductors are also not dependent on a power source. I mean, if you're using it for something, obviously you will need it, but there won't be anything lost to resistance. It's also frictionless and cold, much like space is. So that's why I chose a similarity between the two. So basic physics principles, everybody knows what conductors are and Ohm's law. Volts equals current times resistance. You lose whatever your current is by the resistance. That's why you need to continue a power source for this to continue working with basic conductors such as copper, gold. Um, Everybody's pretty much familiar with all that. You need a power source to keep running. You will lose energy to resistance. And the reason this is happening, I mean, more or less, is that electrons are moving and bumping into each other in the process. You lose energy to heat and you lose energy to friction. So that's why we need a continued power source for basic conductors. Now let's move on to superconductors. Okay, so superconductors are a little bit more difficult to explain exactly what they are. They're like a mishmash of synthetic materials. It's not exactly like one thing I could call out like copper or gold. Although some of the original ones, I think, were like mercury or quicksilver, was one of the first to be found that actually was a potential superconductor if you got it cold enough. There is absolutely no loss in current or energy when using superconductor materials at this near absolute zero temperature. One-to-one ratio, and I mean not an exact, but like in our old Ohm's law, V equals IR. This is not exact, but imagine V equals I. What you put in is what you get out, and it can just keep going. There's no heat buildup in this, and there's no resistance, so the resistance is eliminated in superconductors. Here is a graph showing the non-superconductive metals like gold or copper. As it gets lower, the temperature, the resistance lowers, but it never actually reaches zero. Whereas superconductors, you reach a certain temperature where it's called the terminal or critical temperature, and it just drops down. There is no more resistance once it reaches this. And each one's a slightly different to whatever material you're using. But when it reaches that, resistance is gone. So that's pretty cool. So my analogy. In space, shuttles or comets can travel without a continuous engine thrust. Once you put in whatever energy it is, it'll just keep going. There's no friction in space, so there's no loss in velocity. If you're eliminating gravity and comets hitting bumping into each other or whatever, just in the void keeps on going. So superconductors can conduct electricity without the continuous power source. Once you put in whatever it is you're putting in, it'll just keep going until it's used for something or you draw it out. But if you don't, it keeps on going. There is no resistance in near absolute zero, and there is no current loss. So in this way, it's much how like objects just keep flowing on through space. They just keep on going, kind of like superconductor current just keeps on going. And the revisions I made to this was just to add several new images. I changed the background color and the text color to white to make it look more space-like. And hopefully it adds a more space theme. All right, well, thanks guys for watching my presentation. I hope everybody enjoyed it. Thank you.